All right, we're going to be talking about simplifying a rational square root. Now, a rational expression is just anything in the form of a fraction. So this could be something along the lines of, say, 100 over 81. And this whole thing is under a radical. Now, one of the properties that we're going to be using here is we're going to be essentially using the property that if I've got one thing, an entire rational thing under a radical, this is going to be the same thing as having the square root of 100 over square root of 81. It's the same thing as having each of those things, both the numerator and the denominator, under separate radicals. And then we could just evaluate that. So that's going to be 10 over 9. Now this is the easy way of doing this. So, and I'll go ahead and put this out here. So this is kind of the broader property. It's this square root of a over b is equal to the square root of a over the square root of b. This only works with multiplication and division. This never works with addition and subtraction. So here's what we're going to do. This is what works for items like this. But occasionally you're going to run into something that's a little bit sneakier. Say we've got something like, oh, I don't know, 25 over 3. Well, this would be square root of 25 over the square root of 3. And I could evaluate that. That would be 5 over the square root of 3. But I'll tell you, it's kind of it's a bad form. It's not fully simplified to have a square root in the denominator. So we're going to do what we call rationalize the denominator. And with this, what we're going to do is we're going to look at this denominator and say, well, what do I need to do to make this a perfect power? What do I need? Well, this, instead of being just a 3, this would need to be a 3 squared. Well, I can make this a 3 squared under that radical. I'll just need to multiply that by the square root of 3. Square root of 3 times the square root of 3 would be the square root of 9. Okay, but whatever I do to the denominator, I have to do the same thing to the numerator. And notice, once again, we're multiplying by a well-chosen 1. So up in my numerator, I'll have 5 square roots of 3. And then then I can evaluate that denominator. So this would be 5 square roots of 3 over 3. And we'd be done with that one right there. And there's all sorts of things that we can do with this sort of thing. Now, there's some trickier examples, and I will talk about them later. And it has to do with some addition and subtraction in our numerator or denominator. But let's just keep going over some more examples of this. I'm going to do the square root of 8 over the square root of, how about I do the square root of 6. Okay. Here, I can actually start to evaluate this. Square root of 8, that'll be a 4 times a 2 over the square root of 6. So I'd have 2 square roots of 2 over my square root of 6. Well, guess what? I still need to rationalize that denominator. So once again, I'm going to multiply by a well-chosen 1. So now I'm going to have 6. I'm going to have 2 square roots of 12 up top over the square root of 36. And you'll note that I can still I can evaluate that denominator, no problem. But I can also keep doing things with our numerator. So if I look at this, in our numerator, square root of 12 is going to be well, why did I put a line there? It's 4 times 3. So this is going to be 2 square roots of 3. So I'm going to end up with 2 times 2 square roots of 3, 2 times 2 square roots of 3, over square root of 36, which is just a 6. And I can simplify that. So this is going to be 2 square roots of 3 over 3. Now, you might have noticed that you might ask yourself, is there a simpler way of doing that? In some ways, yes. There's a couple things that we could have done here at the beginning. I could have done things like recombined this and said, oh, this is also the square root of 6 or 8 over 6, and then reduce this fraction here to be this square root of 4 over 3. And then said, oh, that's going to be 2 over the square root of 3. And then we multiply that square root of 3 over the square root of 3. And we'll end up right back here when I do, well, sorry, I'd have to do 2 square roots of 3 over square root of 9, which will get us back to here. So we could, there is some wiggle room in our method. And it depends a little bit on how much you're able to look ahead. Most people are more comfortable, I've found, just working just the numerator, just the denominator, and seeing what happens, and then just reducing as you go. Notice that I can't, if I've got, I can't reduce a term that is under a radical with just a whole number in my denominator. These aren't like types. Even though it's a 3, this has a power on it that I just simply can't reduce things like that. So alrighty, I want to give you an example of something that, actually, I think let's do one more example, and I'm going to show you what this would look like if we weren't doing square roots. So let's do something like cube roots. I'm going to do the cube root of 8 over the cube root of 25. Now I can take the cube root of 8. Remember, 8 is just 2 to the 3rd power. 25, however, is just 5 to the 2nd power. So I could evaluate that cube root of 8. That's just going to be a 2. But I can't get this to a perfect cube just yet. This is just 5 squared. I would need to have this 5 cubed. So in order to do this, we want 5 cubed, which is 125. So what I'm going to do is I'm going to multiply this by another cube root of 5. 5 times 25 is 125, or this would be 5 cubed. Now, when I do this, I'll have 2 times the cube root of 5 over, this is the cube root of 125, or hey, it'll be 2 cube roots of 5 over 5. And we'll be done right here. All right, that's all I've got for right now. I will see you in the next video.